Right, good day and welcome. I'm Mr. Simons. This lesson, again, trig functions. We're learning the basics of a tan graph, right? So, to plot my tan graph, set up a table. We're going to plot from 0 to 360, right? I'm going to use 0, 30, 45, 60, 90, 135, 180, all the way to 360. Pass tan 0, I get 0, tan 30, 0,58, 45 gives me 1, 60 gives me 1,73. Put in tan 90, your calculator would say math error, that just means it's undefined. 135 would give me negative 1, 180 0, 2251, 270 again, math error, undefined. Take note, we can't write math error, no? I must write undefined. 315 would give me minus 1, 360, 0. So if I plot 0 and 0, 30 and 0,5, 45 and 1, 61,7. As this line is approaching 90, it will come big, but it will never make contact with 90. Therefore, at 90 degrees, that line that this graph is not allowed to touch is referred to as a asymptote. Right? Then we start at 135, or you have 120. Just didn't put 120 in there, didn't have space. But 120, negative 1,73, 135, negative 1, 150, negative 0,58, 180 and 0, 210, 0,58, 2251, 240, 173. As you can see, in this part, between 90 and 270, I have a complete tan graph, right? 270 again, it's undefined, so that's referred to as an asymptote, meaning this graph in the middle is not allowed to touch 90 or 270. Right? Then start after that. 300 will give me negative 1,73, 315 minus 1, 330, negative 0,58, and 360 and 0. So you should see, if you look at the shape in the middle, that's a complete graph. Draw one complete graph from 90 to 270. 270 minus 90 gives me 180. So period of a tan graph, we say, is 180 degrees. If I take this part and I attach it to the front there, you should see it forms another complete graph. So from 0 to 360, I technically have two tan functions. Right? Now, general features of a tan graph. Right, number one, it has no turning point. The graph don't turn back, therefore it can't have amplitude. If it doesn't have amplitude, it doesn't have a maximum or minimum value. Right? So explain, as A gets closer to 90 and 270, tan A gets so big, but it will not touch 90 or 270. Therefore, these two are referred to as vertical asymptotes. It's tan A equal 90 and tan A equal 270, or tan 270 and tan 90. Right, my period, as I said, to draw one complete tan graph, 180 degrees. My range, my y values, as you can see, that graph can go all the way down till in China. This can go all the way up, right to New Zealand on the other side, right? So therefore, y element of real numbers, or going from negative infinity to positive infinity. Graph for tan is an increasing function. You see, as x increases there, y increases. As x increases there, the y values continue increasing, and as x increases there, the y values continue increasing. So hope you follow. I'm going to be doing another two examples to make sure you get the hang and identify the pattern. Right, so by now, tan A, as explained in the previous slide, period is 180 if I write angle A, for angle A. The small a there in front, which normally represents amplitude, if I change the coefficient to 2, we have to check what happens. Period is 180, range will stay y element of real numbers. So my interval spacing, 180 divided by 4 gives me 45. So you see there's 0 plus 45, plus 45, plus 45, plus 45, all the way through till 360. So my domain I'm drawing from 0 to 360. So tan 0 is 0 times 2 stays 0. Tan 45 is 1 times 2 stays 2. Tan 90, undefined. Tan 135 minus 1 times 2 gives me negative 2. Tan 180 times 2, 0. Tan 225, 1 times 2 is 2. 270, undefined. 315 minus 1 times 2 gives me negative 2, and 360 gives me 0. So all that happened when I put the coefficient 2, see there 45 is no more 1, it simply became 2. 135 is no more minus 1, became minus 2. You can see we've just doubled the values. Again, if we plot 0 and 0 and 45 and 2. 90, we have our vertical asymptote. Then I start at 135 and negative 2, 180 and 0, and 225 and 2. Plot those points. 270, again I have my vertical asymptote. 350, negative 2, 360 and 0. So these are the points that I have to use to plot a tan graph. Right, so hope you understand. I hope you see the shape is the same. One complete tan graph, again just as a period of 180, 270 minus 90. So hope you follow, hope you understand. Wish you nothing but the best. Right, let's look at another problem. If you're enjoying the lesson, please like, share and subscribe. Y equal 3 tan A. So my period still, because it says A, would be 180. My range, as I said, will always be Y element of real numbers. For my interval spacing, 180 divided by 4. It gives me 45, so therefore 0, 45 plus 45 plus 45 all the way through. Tan 0, 0 times 3, 0. 45, 1 times 3, 3. 90 would be undefined. 270, undefined. Rest, you can punch in your calculator and verify if you get the same answers as I do. If I plot 0 and 0, 45 and 3, draw the graph up, but it must not make contact with my vertical asymptote at 90 degrees. Then I start at 135 and minus 3, 180 and 0, 225 and 3, and join those points, and I have one complete graph, but take note 270, my other vertical asymptote. Then again I start 315 and negative 3, and 360 and 0. And there's a tan graph drawn completed. Hope you enjoy the lesson, hope you understand, hope you follow the pattern that I'm trying to show you in the lesson. God bless. Bye.